Have you ever looked up at a wind turbine and wondered what happens inside? From the ground, turbines look simple. A tower, 3 blades, and a box on top. Inside that box, the nacelle, industrial machinery converts variable wind into controlled electricity. What looks static from the ground is constantly adjusting inside. In this video, I'll walk you through the internal components of a modern wind turbine. By the end, you'll understand how those systems work together. Most of the machinery sits inside the nacelle. This enclosure is mounted at the top of the tower, directly behind the rotor hub. Inside are the drivetrain, the generator, braking, control and orientation systems. Utility-scale nacelles are substantial structures. They're often about 50 feet long, weighing 60 to 80 tons, depending on the configurations. Offshore machines are still bigger, with nacelles weighing several hundred tons. This arrangement is designed to manage load, vibration, heat, and allowing access. Many turbines use a gearbox as part of the drivetrain. The gearbox connects the low-speed shaft from the rotor to the high-speed generator shaft. Rotor blades turn slowly, typically 8 to 20 rotations per minute. Generators need higher speeds to operate efficiently. The gearbox increases speed to roughly 1 to 1800 rotations per minute. Gearboxes run under heavy variable loads and conditions. They're built to withstand changing wind forces, vibrations, torques, and temperatures. After the gearbox, the generator converts mechanical energy into electricity. Copper windings move within a magnetic field, producing alternating current. Now that electricity flows through power electronics and transformers before leaving the turbine. The generator is driven by the high-speed shaft. Its size and cooling approach depends on turbine capacity and the overall configuration. Wind turbines include braking systems, but the brakes do not regulate power during normal operations. The blade pitch control handles power and speed. Brakes act as a safety system. They stop the rotor for maintenance or during extreme conditions. If pitch control can't slow the blades sufficiently, brakes bring the rotor to a stop. Now, some turbines use mechanical disc brakes. Others use generator braking by altering the mechanical resistance. The goal is controlled deceleration without any damage. The main shaft connects the rotor hub to the drivetrain. It carries high torque at low rotational speed, typically around 30 to 60 RPM. In gear turbines, the main shaft feeds directly into the gearbox. In direct drive turbines, it connects straight to the generator. Direct drive removes the gearbox, but increases generator size and weight. Both approaches are widely used. A turbine is efficient only when it faces the wind. That orientation is handled by the Yaw system. The yaw drive rotates the nacelle. Yaw motors provide the force. Together, they keep the rotor aligned with changing wind direction. Yaw systems are used on horizontal axis turbines. Yaw movement frequency depends on how variable wind conditions are at a particular site. Wind data comes from onboard sensors, and one of the most important is the anemometer. It measures wind speed and, with other sensors, helps determine direction. This data feeds continuously into the controller. It informs your position, blade pitch, and operating state. Accurate measurements supports stable, efficient operation. The pitch system controls blade angles. This is how turbines regulate power. Adjusting the blade angle changes how much energy is taken from the wind. Pitch controls limits speed and structural load during high winds. It operates continuously during normal operation. The controller coordinates the entire turbine. It determines when the turbine starts and stops. Operation typically begins around 7 miles per hour, and shutdown occurs if wind speeds exceed 50 to 60 miles an hour. When conditions return to safe levels, the turbine restarts automatically. The controller integrates data from sensors, pitch, yaw, and drivetrain systems. If you're considering a wind project for your land, start by checking whether the site meets technical requirements. Download our free wind farm checklist using the link in the description below to assess the suitability of your land. If you found this video useful, please subscribe for more videos just like this one.